Okay, great. All right, welcome everyone. Sorry for the delay here. Welcome to SciStarter Live. This is another one of our weekly webinars. Today we're going to be talking about the Girl Scouts and NASA Globe Protect the Planet, the trees, or Globe Observer trees, excuse me. That is a very enjoyable measuring trees activity. So, and we'll get started with that momentarily. But first, we'll do a couple of introductions. So, my name is Emma Giles. I'm a program coordinator for SciStarter, and I'm usually the one here talking to y'all as the host. And also online, we have Roland. Do you want to introduce yourself?
Thank you. Hi, everyone. I'm Roland, joining from Beirut, Lebanon, and I'll be your IT support today. In case you need anything, please feel free to put it in the chat.
Excellent. All righty. And then we have a couple others on the call with us. Would you like to introduce yourselves? Kaylee, go ahead.
Hi, everyone. I'm Kayla Mckenna. I'm part of the Girl Experience team at Girl Scouts of the USA, and I help to lead our STEM program. I'm coming to you from New York, New York. I've been at Girl Scouts for about 5 years, and I have the awesome job of developing programs for girls in things like robotics and citizen science.
Brian.
All right, I'm Brian Campbell. I'm a NASA Senior Earth Science Outreach Lead at the NASA Wallops Flight Facility in Wallops Island, Virginia. I'm also the Tree Science Lead for the NASA Globe Observer, the lead for the Trees Around the Globe Student Research Campaign, and the Education Lead for the NASA Ice Cloud and Land Elevation Satellite. And I'm excited to talk to all of you today.
Awesome. Yeah, we've got a full team today. It's excellent. Darlene, would you like to introduce yourself?
Oh, sure. I'm Darlene Cavalier from Arizona State University and from SciStarter, and I am tuning in from Long Beach Island, New Jersey.
Awesome. All righty. So, and we will come back to our lovely guests momentarily. But before we get started with that, I just want to set a couple of expectations towards the tools you have here. You have both the chat and the Q&A function available to you as an attendee. So if you have any questions or comments or anything, you can add them into the chat, and you can direct message Roland, IT support, if you need anything from him. We do have the Q&A option, so if anything comes up that you want to ask about the project, about SciStarter, about citizen science in general, we are happy to answer that throughout, and we will have some time at the end to address that as well. Awesome. All righty. And just to practice it, if you could write into the Q&A where you are from, or not Q&A, sorry, the chat, where you are.
Emma, can you allow for everyone to be an option so they can post their comments to everybody? Thank you.
So sorry about that. There we go. Yeah, you should be able to now. So you can go ahead and write into the chat where you are signing in from. I am here from Phoenix, Arizona, where it is nice and cool this morning. Thank goodness. Awesome. Oh, awesome. Okay, we've got North Carolina, several North Carolinas, Washington, Maryland, Florida, New Jersey. Hope everyone signing in from Florida is in a safe place. Kansas, nice, awesome. Okay. Let's go.
Maine, Washington.
So many. Awesome. It's great to have you all here. Awesome. All right. Well, while we are going over where we're all from, I just want to preface by, if you would like to participate in the Globe Observer app, I just want to plug this first, just so you can get this settled while you are listening in on the other things. So we do have the app available to you in the App Store for Google Play and the Apple App Store. And it has 4 different projects on it. So you can look at any of them. The one that we'll be talking about today is the trees one at the very bottom. But you can go ahead and download that while we're working if you want to follow along with us later. Okay, awesome. Alrighty, so before we get started with anything else, we're going to start to understand who you all are so we can know who we're talking to. So we're going to start running some polls. First one is, have you ever participated in citizen science before? Awesome. Got about 70, 80 some % of you have participated, and you can go ahead and end that. All right, excellent. A majority of you have. That's awesome. 82% of you have. Welcome back. We're excited to have you here. Awesome. And then also another question for you. Have you ever been to one of our SciStarter live events before? This is every Tuesday at 2 p.m. Eastern or 11 a.m. Pacific right now, or if you're in Arizona. Awesome. 73%, 84% of you. Couple seconds here. Excellent. All right, cool. Most of you have not. Well, welcome to the team. We're happy to have you here. And for those of you returning, I'm super excited to have you here too. That 31% of you, welcome. Awesome. All right, and then last one, we do want to know exactly why you're here. So are you an aspiring citizen scientist, a student, a parent of an aspiring citizen scientist, a teacher, educator of some sort, troop leader, Girl Scouts, a librarian or part of library staff, researcher or project leader, or a board person on the internet? 72% of you. Give you a couple more seconds. Okay. Awesome. Great. Okay, cool. Oh, awesome. All right, so 47% of you being a teacher, educator, troop leader. I'm hoping we have quite a few Girl Scout troops on here. That would be excellent because this is the best project for you. Awesome. Okay, cool. All right, so we'll just keep moving on then. So just to give some context to anyone who is not as familiar as the rest of us with citizen science, for SciStarter's definition, and there are many, citizen science is a collaboration between scientists and those of us who are curious, concerned, and motivated to make a difference. It's how people can make an impact on issues they care about and help science. So we're excited to have you all involved in that. And the first step, whenever you want to do a citizen science project, is to go to SciStarter, because we have that giant online citizen science hub where you can find many projects of all different topics. So you can search for the right one that fits your needs and your curiosities. Okay. In addition to having all those projects on the site, we also have some free trainings for you, including a foundations training to get an understanding of what citizen science is and how you can best be a citizen scientist. Excellent. Alrighty. So today being a focus on the Girl Scouts and our partnership with them, I'm gonna give it over to Darlene to help explain that partnership for us.
Great. Yeah, so maybe Roland or Emma can drop a link into chat where they can find the main landing page for information about our wonderful programs that we have with our friends at the Girl Scouts. And there's actually a couple of programs that we have. So we can go to the next slide. And that's for Emma or Roland to advance the slide. So one is this one, and this is a fun one that has a limited time. So now, and Kaylee will give some more information about these. So I'll just give them. Actually, Kaylee, why don't you talk? It's your programs.
Yeah, thanks so much, Darlene. Yeah, so today I'm going to share about 3 awesome Girl Scout programs that incorporate citizen science and SciStarter. First, I'm going to share 2 that are open to everyone, and then we're going to talk about one that's just for Girl Scouts. If you go back to the last slide real quick, you'll see here that, like Darlene said, you can find all 3 of these projects on the new Girl Scouts SciStarter page, which you can find right there in the top link, the top menu on SciStarter. So next slide, please. So first, I'm excited to share more about our newest national challenge. It's open to everyone, and it's running now through the end of November. The Girl Scout Climate Challenge asks you to get outdoors to learn about climate science, connect with your community, and spread awareness to help create lasting change. You could choose from a variety of activities that connect climate science and climate change with other parts of life, such as outdoor adventures, community problem solving, and advocacy. The challenge includes activity guides and resources for K-5 and grade 6 to 12, as well as an adult resource. All of the materials are available in Spanish and English, and there's also this brand new patch. Next slide, please. So to help support everyone working on the challenge, Girl Scouts and SciStarter have created a specially curated page of citizen science projects that connect with climate. So in particular, you'll see here on the bottom middle that you can participate in Globe Observer Clouds project, which uses the same app as trees, which you'll hear more about today. Next slide, please. So next, you can join the Girl Scout Tree Promise, which helps to protect the planet from the effects of climate change. The Girl Scout Tree Promise aims to protect, plant, and honor 5 million trees across the country in 5 years. Not only is this good for wildlife, it'll also help ease the effects of climate change. Already, we've planted trees in over 50 states and globally, so we'd love for you to join us. And by helping us to plant, protect, or honor trees, you'll also have access to this tree promise patch. Next slide, please. And as part of protecting and honoring trees, you can also participate through SciStarter. So just like the challenge, we work together to create a special curated page with tree-related projects. You'll see right there in the middle under Honor Trees that there's Globe Observer Trees Project, which Brian will share more about in a little bit. Next slide, please. So finally, I just want to share with you a program that's just for Girl Scouts. Again, those first 2 programs are open to everyone, girls and youth of all ages, where this one's really just for Girl Scouts. So through the Think Like a Citizen Scientist journey, Girl Scouts of all ages, they have the opportunity to explore how scientists solve problems. You'll find out how citizen scientists make observations, collect data, and help scientists conduct research through a project on SciStarter. You'll also create a take action project that helps your community. Remember, this program, is only for Girl Scouts. So if you aren't a Girl Scout, you can get started by joining at www.girlscouts.org/join. Next slide, please. So, and just like the other programs, we partner with SciStarter to create a really special experience, apologies, for Girl Scouts and volunteers. Through the Girl Scout portal on SciStarter, you can track your, sorry about that. You can track your progress for projects like Globe Observer and also share your Take Action project. Girl Scouts, if you're interested in the journey, you can let your troop leader know. Volunteers, you can get started through the volunteer toolkit where you can sign up for SciStarter and share a unique link with you. And remember, if you're not a Girl Scout, there's still time to sign up for the troop year. Again, you can go back to the last slide and you can find that link there. And so with that, I'm going to hand it back over to Emma. Thanks so much.
Excellent. That was a ton of information. If anyone has questions about any of those things, feel free to drop them in the Q&A and we'll make sure to address these as we can. But yeah, okay, that is a great lowdown of all those different programs. Thank you so much. All right, so because today we're going over a very specific project, here is that project again, the Globe Trees. And if you needed a reminder of where to go, this is what the app looks like for downloading it. And I'm going to go ahead and just go through real fast how you can connect this app to your SciStarter account, because this is essentially the way to get credit for all your work, and you can keep track of how well you do or how often you participate over time. So this is all the steps, but I'm going to go ahead and show you pictures instead so it is better understood. So first of all, by downloading the app, that's awesome. You log in and create an account with the Globe Observer app. And then once you've done that, you're going to hop over to the settings place. So once you have the app downloaded, you're all set. In the app settings, which is at the bottom right-hand corner area, it'll be right here. It's invisible right now, but when it is there, you'll find app settings. And in here, it's an entire button dedicated to connecting to SciStarter, and it's as simple as that. Once you tap that button, you'll be taken over to the login within the same app, just as the web browser. And you just sign into your SciStarter account and ta-da, it just about works. Yeah, it'll give you a little success message, and then you'll know that every time you sign on, it'll automatically start crediting it to your account. And then you can just go ahead and get started. This is the welcome page for the Observer Trees project. And I'm gonna go ahead and pass that over to our other guest, Brian. Here you are.
All right, thank you, and thank you, Kaylee, for all the awesome Girl Scouts information. We're super excited to always work with the Girl Scouts, with SciStarter and NASA and the Globe program. So, thank you. So, yeah, so we're going to talk a little bit about trees today, and we have this awesome challenge coming up, actually starting a week from today. And basically what you have here is, just a little rundown of some specific things. The Globe Observer Trees, it allows citizen scientists, volunteers to measure tree height and, an optional measurement of tree circumference. If you happen to have a tape measure, not many people always walk around every day carrying a tape measure in their pocket. But if you happen to have one, you're going out to measure trees, take one with, because that data, and you'll see in a little bit in one of my slides, that the tree circumference is just as important as the tree height, but we make it optional because people don't always carry a tape measure around. I'll expand a little bit more about tree height as most widely used indicator of environment ability to grow trees. Also, in the scientific world, tree height and tree circumference really is a great indicator of how our planet is responding to a changing climate. And I'll get into that in a bit. Next, please. So with Globe Observer, we have an amazing team, spread out through the United States and, and some folks globally. On the left here, you see the research team. These are folks who lead the Globe Observer, the project communications, project managers and things like that. You can see Dr. Dixon Butler, if you know him. He's, was once the Globe chief scientist, and now he has this Y Lacey's program. But then you have lots of folks here coming from different angles. They're scientists, researchers, educators, communicators, managers. So this whole team that we put together really focuses on how to bring that citizen science data into the real world and how it makes sense and how it ties into things like NASA missions, which I'll get into in a second. Next, please. All right, so when you join, the Globe Observer, not just trees, because there's several other things, as you may know, as part of Globe Observer. You can do clouds, mosquito habitats, land cover, and trees. And, soon, every once in a while, we bring in where you can bring in eclipse data. You can add eclipse data, into the Globe Observer app. And the GLOBE program, the Global Learning and Observation to Benefit the Environment, is an international network of citizen scientists and scientists working together. We're active in 120, Globe's active in 127 countries right now. And, all the data that comes in can be used for student and professional research. Okay, there's over, I think by now, about 230 million points of data, meaning measurements from students, teachers, educators, citizen scientists in the GLOBE database since essentially 1995 when the program began. Next, please. All right, so this is kind of the steps, and I'll go through this a little bit further on, but with this trees challenge, we have, we want people to go out and take as many observations as possible of trees in their local environment, whether, it can be also when you're traveling somewhere, you might be visiting somebody or visiting a relative where you can take these observations as well. But basically what you're doing is you're measuring the height of the tree by using your phone, your mobile device, as what's called a clinometer. A clinometer is an instrument that's used to measure slope and angles. So we programmed the app to work with basically as a clinometer. The phone has an internal magnetometer that can be used to measure angles. And when we do this, we can use your phone as a clinometer. So you're gonna figure out what the angle is to the base of the tree, to the top of the tree. You're gonna walk to the tree. And what you do is you're actually calculating some trigonometry, which we programmed into the phone. But by measuring those angles and putting all those angles together, we've set it up that the trigonometry programmed into the phone will allow you to estimate the height of the tree. Next, please. You can go to the next one. Okay, so with this, looking at trees and tree height, I'm going to get in a little bit more about the importance of it, and you can go to the next one, please, because that is the reason why we created an app and invested so much time, in this, because the data that we're getting from this is amazing. And we have so many trees on our planet right now. We have approximately 3.03 trillion trees on Earth with about 78,000 tree species. So each one of these trees is an indicator of a changing climate. So tree height is the most widely used indicator of an ecosystem's ability to grow trees. Let's think of it this way. Let's think of two different types of environments on the planet. Let's think of the Amazon rainforest and let's think of the Sahara Desert. Two environmentally different places. We have the Amazon rainforest where we see lots of trees growing tall. Why is that? It's because we have the right amount of precipitation. We have the right amount of organic matter in the soil. We have basically the right nutrients in the soil. We have the right amount of sunlight. So we have those ideal conditions for growing trees, tall and lots of them. Conversely, if you think of the Sahara Desert, you don't necessarily think of a desert of growing lots of trees. You may see shrubs here and there, the dry, shallow-rooted shrubs. Why is that? Well, that environment where we don't see these trees, and if we do see some of the trees, they're definitely not very tall, is because we have a hot, dry, arid climate. We have an area where the soil is not very nutrient rich. It's a sandy soil, so that a lot of the trees that may grow there or shrubs are very shallow rooted. And if there is precipitation, which there's not much of in this area, in these deserts, this type of precipitation, when they get rain, because the grains in the sand are so densely packed, we get a lot of flooding and runoff first before it gets a chance to percolate or infiltrate into the soil. So with that said, at NASA, specifically where I work, for the last 22 years, at NASA, we have scientists who are looking at tree height from space, okay? But they need your data on the ground through the GLOBE program and the NASA GLOBE Observer Trees tool, because all that data combined can help us understand the gain or loss of biomass. Now, biomass is basically the amount of organic material in a particular area. At that biomass, because every single tree on the planet pulls in carbon dioxide from the atmosphere via photosynthesis. We pull in the carbon dioxide through photosynthesis, and it's converted into the oxygen we breathe. So knowing all that for the trees, if we know where the trees are and we know how tall they are, we can estimate how much carbon dioxide each one of those trees, or even like a large forested area like the Arctic boreal landscape where there's millions of these huge pine trees, okay, we can estimate how much carbon is being pulled out of the atmosphere and essentially being stored by these trees. These trees have carbon in them, right? They're made from carbon. So this carbon that's being pulled out of the atmosphere, through photosynthesis and the growth of the trees and the carbon sequestration, what happens here is that as a tree grows, it's storing more carbon. So all this carbon is stored in the trunks, in the roots, in the leaves, in the branches, all these things. And that in turn, all that information helps us understand our planet's carbon budget, basically how much carbon is being pulled out of the atmosphere versus how much carbon is being sent into the atmosphere, carbon dioxide. So we're trying to get that balance down where there's more carbon dioxide being pulled out of the atmosphere than there is being released into the atmosphere, through areas, like maybe big cities or, lots of people, lots of automobiles and factories and businesses, places like that, who are using that energy and then sending all that carbon dioxide into the atmosphere. We're trying to offset that. And one way we can do that is plant trees, okay? But when we plant trees, we have to eventually figure out their tree height so we can estimate how much carbon is being pulled in. And I'm going to focus now on, go to the next slide, please, on a couple missions here, okay? There's a couple missions in space right now, NASA missions, and the first one is called JEDI. It's a Global Ecosystems Dynamics Investigation. If you're a Star Wars fan, that's awesome, because this is kind of a play on that, because the tagline for the JEDI mission is, "May the forests be with you," okay? Because this is an instrument on the International Space Station that can send laser pulses down, these red laser pulses from the instrument to the tree canopy. So what we do is we calculate the time it takes the laser pulses to leave the JEDI instrument, bounce off the canopy, the tree canopy in forested areas, and then come back to the satellite. Sorry, back to the International Space Station instrument. When we do that repeatedly, we can see how tree heights are changing over time. Are they getting bigger, smaller? Are we losing trees? Are we gaining trees? Things like that. We have another mission called the Ice Cloud and Land Elevation Satellite 2, or ICESat-2. And it sounds funny that I'm actually talking about an ice, cryospheric-based satellite when we're talking about trees. But because it's an independent satellite, it's called a near polar orbit, so it moves around the North and South Pole, about just over 15,000 miles an hour. But as it's doing that, it's also sending laser pulses down at 10,000 times per second. And in each one of these laser pulses is approximately 300 trillion photons. So our objective is to send these laser pulses down like JEDI, send them down super fast, and get as many back to the satellite as we can after they bounce off an Earth's object. Now, ICESat-2 focuses on the cryosphere, so it's focusing on the melting ice sheets of Greenland and Antarctica, and the melting sea ice around the Arctic and around the Antarctic Peninsula, by figuring out what's called a mass balance of this, how much ice is lost versus gained every year. But because it's a laser, what's called a laser altimeter, an altimeter measures height or elevation. The altimeter, we can measure the height of trees, and ICET2 has the potential and has done this already since its launch in 2018, September 15, 2018, to measure the height of trees, individual trees and grouping of trees. Next, please. So you can just, click on that video right there, and I'll talk through this while we're going. The one in the middle, yeah.
Sorry, it might send me to a different location. Hold on.
Okay.
I'm gonna stop my share so I can reshare. Okay, there you go. Oh, do you need audio in it?
No, that's fine. No, that's fine.
Okay.
So what this is showing is, and I'm not going to show all this, but this is just showing you when the ICET2 mission got launched, this is what the artist's rendition of what's happening. So basically what's happening is the satellite was launched into space. The solar panels unfurled, this door opened up, and then the laser altimeter, little hole here, started firing out these laser photons at 10,000 times per second. And so we're, reiterating again, we're calculating the time it takes for the laser pulses to leave the satellite, bounce off an object like trees, and then come back to the satellite. And with that information repeated over time, we can figure out how tall the trees are. Okay, next slide then.
Okay, there you go. Is this another?
All right, so here we have Jedi. That's fine. We won't show the video on that, but this is Jedi. So this is just showing a little bit more. So what Jedi, the difference between Jedi and ICET2 is, one is, since Jedi is on the International Space Station, it's a single instrument. It's not an independent satellite like ICET2, but because it's in the orbit, it has to be in the orbit of the International Space Station, which is between 51 degrees north and 51 degrees south latitude. We're only measuring any trees that are within that area. And when you combine that with the ICET2 data, we can get amazing global coverage of tree height. But another reason why I mentioned both of these missions is that because the satellites can't see everything. They can see a lot. They can't see everything. That's why we need tree height observations from the ground, because there are things that get in the way, like clouds. Really thick clouds are really bad for lasers, because they can't penetrate them. We also have some clouds called cirrus clouds. You've all heard of those, the wispy, feathery looking clouds. Those are made out of ice crystals. And when the laser pulses and the photons hit the ice crystals, we get a lot of refraction. So, you can imagine we're sending the photons down from the satellite, hit an ice crystal, and it gets scattered or refracted in different directions. And it doesn't actually travel through to the Earth. Some do, but the majority don't, because of this ice crystal makeup. Next, please. You can go to the next one. It's fine. So with this, we're going to talk a little bit about the Globe Observer Trees tool. Since I talked about why NASA cares about it and why you should care about it, how NASA is measuring these things from space, okay, we have the ability to take tree height observations from the ground. Everyone has this ability just by using a mobile device. And if you could show the video on the right, is it's basically a teaser for kind of what I just mentioned. It's about 50 seconds. So it's a teaser about taking the tree height measurements and how you can potentially compare the ground-based data from Globe, your tree height observations, to NASA's satellite data. And there is sound on that one too. It's just music.
Sorry, it'll play in 2 seconds. Oh, I'm sorry. It's not going to have sound for it. Can you describe?
That's fine. Yeah, that's fine. There's words on it anyway, so that's fine.
Okay. Are we seeing the right one?
Yep, that's right. So yeah, it's basically starting off talking about, we have this satellite in space called ICET2 that's measuring tree heights on Earth from space. And we compare the elevation of the ground to the top of the forest. But then you can go into the NASA Globe Observer trees tool and take observations. So basically the satellite's looking down to the top of the trees and you're looking up at the tree. So you can go out and, pick a tree, any tree that you see, and you can just use your phone. And it does take a little practice to be able to get it right, because, and I'll explain in a second, about how you're supposed to hold your phone when you're taking the observation. But when you do this, you'll eventually be able to do it in probably about a minute's time. And, it's so easy to do and it's fun to do, because I like, my son's 15 and, he still likes to go out and say, oh, I think that tree is about, 10 meters tall. And we go out and take a measurement. And, if it's close, he gets super excited. If it's not, he wants to make sure we do it again to see if we get closer to what his guess was. So, it's a lot of fun to do. We'll go to the next one then. All right, so with the observation, the 4 most important things to remember here: you only take NASA Globe Observer observations if it's safe and legal to do so, meaning don't go on other people's property unless you have their permission. Be cognizant where you are. We've run into people want to take tree height observations of trees, in an urban environment in the city. Well, you have to watch out, because you don't want to have to back up into the middle of the street to take this tree height observation. So make sure you know your surroundings and everything is good to go. Also, when you choose a tree, you have to make sure you're able to see clearly the base of the tree and the top of the tree, and be able to walk to the base of the tree in a straight line with no obstacles. Because if you can't see the base of the top of the tree, you won't be able to angle your phone correctly. If you can't walk to the base of the tree in a straight line, what that means is you're going to be adding steps to that, basically that part of the triangle in that trigonometry, and it's going to result in an erroneous tree height measurement. Probably the most important one, I probably should have had this first, is always keep your cell phone's camera at eye level. And what that means is that when you hold your phone up at eye level, when you go into the app and you do the introduction, it's going to ask you for your height. And the app will estimate that your height of your eye level is about 4 inches below the top of your head. So for instance, I'm 6'7" and my son is about 5'9". Okay. If I would hand him my phone without going in and changing the height of the observer, meaning if he'd be doing it and it still says he's 6'7", the phone will think that his eye level is as tall as I am. So he will get an erroneous tree height. In the app, there's a spot where you can change the user settings to change the user height. Okay. But when you keep the cell phone at eye level, you always have to keep it there, because, what you want to do, just normally is when you look up at something. So you're holding your phone in front of your face, keeping the phone at eye level, and you're just going to turn your wrists down to the base of the trees in view, and then turn your wrist up to the top of the tree. You don't want to lift your arms up or down, because that changes the angle completely of what you're measuring. So that's super important. You always keep it eye level, and that takes practice. That even took me some practice to not want to do that. You want to move up and down just naturally, but you can't do that. And then, as I mentioned here, always make sure you have the correct height. Now, also, we have that optional observation of tree circumference. And that's super important, because when you get the tree circumference and you include that plus the tree height, you can estimate, as I mentioned earlier, how much carbon those trees have potentially pulled in from the atmosphere over their lifetime. And through a series of equations that scientists use, the scientists can figure out then an estimated age of the tree based on the tree height and the circumference. So that's super important, because the age of the tree is very relevant to understanding how much carbon is being pulled in from the atmosphere, and also the size of that tree, the height of that tree. Next, please. All right, so this is currently right now where all the tree heights are coming in from. Okay, these are where the tree heights are coming from. And you can see here, these are ones from the GLOBE program. You can see the United States up here. There's a couple, anybody who's coming from that area in the Midwest, we need some more tree height observations in there. I know a lot of them it's pretty remote out there, But yeah. And then in the middle, it's showing you globally. So right now there's approximately 58,000 tree height observations from about 20,000 global locations. And that's a big number for people actually just going out and taking measurements, okay, on the ground. Now, granted, the satellites and instruments have taken literal billions and billions of tree height observations, but there are a lot of trees that globe observers here were able to measure the tree height of, but the satellites have not been able to measure those tree heights yet. What I'd like to do is, like, when my wife and I and son are driving around places, I like to see where there's like an individual tree. And then I'll go into a database called Open Altimetry where we have all the ISAT2 data, and I'll look to see if ISAT2 measured it. And if it didn't, I'm like, oh man, I hope it does, hope it measures it soon so I can do a comparison, but I'll go out and take a tree height measurement of that tree anyway, in hopes that ISAT2 will measure it. Then we can do some comparisons between the ISAT2 data and the globe data. So with that said, can you move to the next slide, please? All right, we're gonna hold it there, okay? This is all about the trees challenge. But Emma, what I'd like to do now is, can we do a quick demo of the app? And I can run through it. Emma was so kind to do a demo, a recording of the app, the trees tool, when she was outside in Arizona, I believe. And I'm gonna walk through this. This is what you'll see when you do the observation. Okay, so this is that landing screen here, and you're just going to go in here. You know, it's just going to be like new tree observation, and then it's going to take you to kind of the things that I said, and then it's going to give you the local time, and then it's going to ask you these service conditions, because we want to know what's happening in the environment when you're taking these observations, because it's super important to know what's going on here, because it helps us understand what the environment that the tree is in. And then when you hit next, it's going to ask you to select that tree, and then you're going to measure the tree base. So your camera is going to open up when you hit this. You probably, for the first time, you might have to give give the app access to your camera. It'll ask that first. But then when you go in here, you're just going to click measure tree base, and you're going to align the base here, this dotted line, to the base of the tree. Remember, holding your phone with the camera at eye level all the time, and you're angling your wrist down to where it gets there. If you like it, you hit yes. If you don't like it, you hit no. Okay, if you don't think it's where it should be. Okay, and if you like it, you can say yes, and then it's going to say measure the top of the tree, measure to the top of the tree, and then you angle. This is kind of the hardest part, because your tendency is to raise your arms up or like lean your body back to see the top of the tree, but you can't do that because you change the angle. You just got to move your wrists, you know, with the phone in it, without moving it away from eye level. All right. So then it's going to ask you to take a picture of the tree, and this is what goes into the globe database as well. That's those maps that you just saw with the pictures on them. This is a picture that you see, so you can go into your area, find that picture, click on it, and you'll see all the data that you submitted for that tree: the tree height, the location, the latitude and longitude, all the surface conditions, and all these things, and a little graph will form as well. And then what you're doing here is you're pacing to the tree. So based upon the height that you put in for the introduction section, okay, it's going to estimate your stride. The app estimates your stride. And when it does that, you're going to walk to the base of the tree just normally, okay, counting your steps. And when you count your steps to the base of the tree, once you get to the base of the tree, you put in how many steps it took, okay? Now, there was something earlier in the app that you may have seen, that if you're in an area where you'd have to walk up a steep hill to the base of the tree, or down, you know, a steep a decline to the base of the tree, your pace is going to change. So we recommend that wherever you stood to take the picture of the tree and did the angle to the base of the tree and the top of the tree, wherever you did that, place a marker and then use a tape measure to measure from that location to the base of the tree. Doesn't happen often, but on a flat surface is where your stride is normal, okay? And when you're walking at weird angles, like up a hill or down a hill, your stride changes. So once you get past that, when you put in how many steps it took, it's going to show you what the latitude and longitude is based upon your phone. And then if you don't like that, you can scroll down, you know, with this, and there's a little map. And if you don't like where exactly the tree is, you can put 2 fingers on the map and then put it exactly where that tree location is. So yeah, it's really cool because sometimes you may be in an area where the signal's not the best, or and you know that that tree is not in that exact spot. You can do that, and then it'll ask you, once you approve that the location, it'll ask you if you want to enter an optional tree circumference, and that is essentially at about 4.5 to 5 meters above. 4.5 to 5 feet above the ground. It's called breast height. Okay, and when you do that, okay, you can then take that measurement. And after you do that, it's going to bring you to, if you enter that, that's great. If you don't, okay, you might not have a tape measure. Just the tree height data is super important as well.
I apologize. I didn't have a tape measure at the moment, so
Oh, it's all good.
I just
So then
showed the
you'll come-
screen.
Yeah, then you'll come to this screen, which is probably the most important screen because it'll give you the camera height. It'll give you all this information, but you have the option, if there's something in here that you don't think is right, like for instance, like your stride, if you happen to, the stride length, if you know what your stride length is and you don't like that 25.1 inches, you can edit that, okay? And then you can, submit it like that. We have this important comments box down here as well. This comments box is important because you can put in things you might see, or the type of tree that you're measuring, or, potentially where it's located, or any other information about the environment around you that you can put in here, because all that information is super important. We call that metadata. All that information is super important for scientists, whether they're student scientists or professional researchers, to look at that data. And then once you hit finish, then that data, it'll say submit to Globe and NASA, and it'll go into the Globe database, and then anybody can go in and access that. Now, I should mention though, there may be a slight delay in it because we actually go through, there's a combination of AI, artificial intelligence, that goes through the system. And then we have people who review these pictures, to make sure that the stuff going into the database is appropriate. So they can, you can click on that button there, and then check mark the box, and you can send it to Globe. All right, I think that's good right there. And I will say, when this presentation is shared, there's going to be a longer video on here where I walk through how to take a measurement. I'm walking towards the base of a tree and doing all that. It's a little longer, so we didn't show it. So, but it'll be there for you to take a look at. All right, we can go back to the slides.
I do want to note for anyone who is thinking that they live in an area where trees are going to be an issue, I have palm trees outside of my complex that I live in, and that's pretty much the closest I get to a lot of like larger trees. So even in areas where it appears like there aren't very many options, you can still get a lot of great data from what is around you. So
awesome. All right, in my last couple slides here, back one, please.
Oh, sorry.
Oh, yeah, that one. So my last couple slides here, the Trees Challenge, the NASA Globe Trees Challenge 2022, Trees in a Changing Climate. Okay, as I mentioned, we have lots of trees on the planet, but we're constantly striving to build and sustain a global inventory of tree height observations and to collect as many tree height circumference measurements as possible. We want to get as many tree heights and tree circumference because that helps us grow that database that researchers can use to understand our planet's carbon budget, to see how much carbon dioxide is being pulled out of the atmosphere, and to see where those trees are. Okay, we know there's lots of these trees, but with a combination of the satellite data and the ground-based data from Globe that you guys will be part of, okay, we're focusing this challenge for 1 month, and it's going to be October 11th through November 11th, 2022. So it starts next week. Okay, next slide, please. And it's going to run through November 11th, and we're hoping to get a lot. So this is kind of, a little recap of some of the things that we talked about, how to do it, how to download, going into the trees tool, be safe. If you have a tape measure, take it with you if you know you're going to measure a tree. And then, if you have a big tree, you might need 2 people, to go out there and do it. It's not always that easy. And then the field notes in those comment sections are super important. Next, please. All right, and this is just a list of some of the awesome resources that we have that you can take a look at. Everything from the actual Trees Challenge page to some of the tools involved in some of this, and a satellite mission, and some other resources as well. add my contact information. So feel free to contact me at any time. And I don't know if you have sound, if you can play this or not. It doesn't matter. It'll be in the slide deck. You don't have to play that because I know we don't have a ton of time left, and know there's some other things we want to talk about. But we created a tree puns video for a challenge last year, and it holds true to this. It's kind of a fun and humorous but educational way to talk about how how you can, the importance of taking the observations and how you can do it using the NASA Globe Observer Trees tool. All right, so yeah, so now it's your turn to try, it's part of the challenge, and we don't want you to just do it for the challenge. We love for you to get started as soon as possible and, submit your data as part of the challenge, but then also, as part of this challenge, and beyond, we want you to continue to sustain, your tree hut observations and to help build that global database, because knowing how tall these trees are, how big they are, really help scientists help to try to make our Earth a better place and understand it just a little bit better.
Excellent. Yeah, that's awesome. I am so glad you gave us such a wonderful breakdown, especially since for selfish reasons, being able to see you kind of look at my observation and pseudo critique it too. It's very helpful. I can already tell like the multiple things. I'm like, oh man, I should have done blah. So it takes some time to get used to, but now that I have all this background, I feel like it's a lot easier to adjust. So thank you so much for doing that. All right, our friends in the call, while we would love for you to be able to get out there and test some trees or measure some trees, excuse me, I do want to know if we have any questions, because there was a lot of information we just went through. I would be thinking to myself, oh my goodness, I have so many questions, but I can't verbalize them. Yeah, thank you, everyone in the chat who's been sharing. Actually, I want to share a couple of them because there is some fun commentary in here. One of our viewers, Karen, is stoked about this and so glad that they tuned in for their daughter. She's working on her Gold Award to design scientific materials involving citizen science concepts to teach kids how to think scientifically, collect data, and analyze data. And I just thought that was so important and awesome to share for everyone who might not have seen it, but that's giant thumbs up there. That's so exciting. Kaylee, actually, I'm curious if you have had any experience working with Girl Scouts that may have had projects related to this. Is that even something that has come up at all? I'm curious.
Yeah, I would say probably, I don't actually have experience myself, but probably a good starting place to look. If you haven't checked it out yet for Think Like a Citizen Scientist, we have a really amazing take action guides that are available with it. So that gives a few different ideas for kind of how you use what you're doing with citizen science or the journey as your spring point for a take action project, which of course you can build into kind of these highest awards projects. So I would say definitely if you haven't yet, check it out. You should be able to find it through the SciStarter link or through BTK as well.
That is awesome. Yes, that was a link at the start of it that brings you to the screen. There are a few questions coming up in the chat, so I'm going to go ahead and go to those as well as a Q&A. We'll go first to what other protocols are part of the Globe Observer app? How do they relate to each other? Why are they part of one app? Oh yeah, Brian, why are they all in one app before?
All right, so with the essentially the Globe program, there's been about 50 different protocols, everything from cloud observation to surface temperature to air temperature and all the everything in between, everything from migration of like the ruby-throated hummingbird and things like that at one point. But we chose ones that are the most, probably some of the most popular ones, as well as some of the most scientifically important ones. And those other ones are clouds. So you observe clouds in the sky around you, everything from, cloud type to cloud cover to contrails and all these different things to try to, and sky color to figure out, what the atmosphere is doing around you. And then we also have the mosquito habitat mapper, which, is super important because, mosquitoes are basically the world's most dangerous creature, and we don't want these mosquitoes around. So, you basically go in and identify potential mosquito habitats, and, you can take pictures of larvae using these little tiny microscope clips that you can put on your mobile device to take pictures, you know, and identify what these are, and then, you know, hopefully eradicate these, potential mosquito habitats. And then we have land cover, which allows you to look at the environment around you and explain and describe exactly what you're seeing. Are you seeing open water? Are you in an urban environment? Are you in a, you know, a built up area? You know, do you see forested area? What types of trees do you see? What types of grasses do you see? And then we have trees. And we also have the eclipse as well when it comes out for special events, when we have either a partial eclipse, total solar eclipse, you know, things like that. But the way they tie in together is, you know, not just, you know, grabbing the ones that are most important, but, you know, all of these different things, you know, play a role in how our planet is, how we have to understand how our planet's responding to a changing climate. You know, our atmosphere is dynamic, it's changing all the time. So every cloud picture that comes in the database, it's different. Okay. We're looking at tree heights, we're looking at land cover. Trees are land cover. So, you know, one thing that we like to say is, you know, when someone takes a tree height observation, you know, with the NASA Global Observer trees, to also take a land cover observation, because trees are part of that as well. So, and I see this just pop in here from April, and I'll continue with this question: is how many trees do you want people to measure for the challenge? And that is a sky's the limit. All right. We would love for you to measure as many trees as possible in a smaller area. You know, if you're in a wooded area and you can measure, you say you have about 200 trees in this wooded area, and, you know, measure as many as you can that you can see the base of the tree and the top of the tree. Okay. Because this allows you for what's called data density. It's a lot of tree observations, tree height observations in a small area. But then also, we like if you could then go in and, you know, take multiple measurements of these trees, because when we do the GLOW program and when the students are out doing the protocol using like a handheld clinometer, what they have to do is they have to take 3 tree height measurements of the same tree, and then then they have to average out what the height of that tree is, because you will see there's always, you know, there's human error involved with all these things, using a clinometer, using the trees tool. So we want to get the most accurate tree heights possible, but we're looking for that data density, because the scientists really want to focus on the most amount of data in a particular area, and whatever area you're in is a good area, okay, if it's just safe to do so. So with a combination of that and all the different protocols together, we're trying to, you know, from the ground, you know, basically study our environment and see how things are changing over time. And, you know, and just each one of these measurements is just as vital as the next for understanding our environment.
That is giving me an excellent picture of how this is working. It's like a giant, it's like a temperature check for the whole world. It's every version of how we can view things. I love that. It's one big picture all together. That's awesome. Okay, we did have a couple other questions. April, what do you recommend for being able to identify tree type? I have used Seek in the past. Is there something that NASA recommends for any of those things, that they want to expand the lesson beyond just the measuring the tree?
Yeah, there's a bunch. You know, I actually use Seek throughout from iNaturalist as well, because, you know, we don't have it set up in the app to identify a tree, because, you know, we want to include it in the comment section, because that would require a whole different step, and might, you know, if we have them do the tree height and then, you know, say, oh, before you can submit this, you need to tell us what type of tree it is, that might get a little daunting. So, but yeah, there are things like, you know, like Seek through iNaturalist and some other ones as well, you know, that you can potentially use. So that's good. I mean, there are books out there as well. You know, you can find local books at like your local bookstore, even a library of, you know, trees in your local area, you know, trees in your region. So that's potential. When I was in Estonia doing some training, I was training students and teachers and other researchers doing land cover and tree height observations. We actually had a local book for the region of Estonia where we were, and then, you know, had to have someone else read it because it's completely in Estonian, but we could identify the trees, you know, every tree that we saw, every shrub that we saw, every plant that we saw. So, you know, look in your local libraries and things like that as well, because I'm sure they have something.
Excellent. I did want to make a note just for the Q&A really quickly. There was a comment that was answered by Teresa, so I just wanted to bring that up just in case anyone wanted some more information. How would you recommend I scale this up for a large group of younger girls, not all of whom have phone access? And Teresa provided a link that should be visible for everyone. and we can send that on as well. But if we want to mention anything else about that, Kaylee, for scaling up for individuals who are not necessarily connected to cell phones or they don't have their own mobiles.
Definitely. A couple other things I would recommend is, because we're talking younger girls as well, it might be great to work in smaller groups. So have it kind of be an adult leading a smaller group, divided by the number of devices. One thing that's also worked well is just taking it back to pen and paper. If it's possible, kind of looking through the app before. Sometimes there's even different data sheets available that you can just fill out kind of as you're out there. So then when you can come back, have access to a device, then you can upload the data at that time. Brian, please call me out though if that sounds like that would not work, but that's what we would normally suggest.
Excellent. Wow. Okay. That's awesome. That's great. All right. We're coming up at the end of the hour. So I'm going to switch screens really quick. Feel free to still write questions into the chat. If there is time, we will address them. If we have our friends here for a couple minutes after the hour, I'm sure they would be happy to answer these questions. But before I lose anyone, I do want to have you mark your calendars for the next events. Of course, we're here every Tuesday at 2 p.m. Eastern. So we have upcoming next week is our mental health day, or October 10th is mental health day. And so to celebrate, we are going to be talking about Narika, which is a project about tracking behaviors and mental capacity it's like video games on a phone to help with dementia research and such. On October 18th, we have Become a Data Literate Scientist. We'll talk about the data literacy training you can take on SciStarter.org. And then on the 25th, because it's so close to Halloween, we will 100% be having a Halloween special, and I am so excited for that. So if we have you for any of those events, I am very excited to see you again. For those of you who are hopping off / before you hop off, we do have a survey for all of you to take. If you are willing to give us some feedback on everything happening during these webinars, it would be incredibly helpful to have your opinion on things. It'll be in the follow-up email as well. So that'll be available to you as well. These are the resources that are here for you to use at any point. You can contact us at info@scistarter.org, SciStarter.org, excuse me, at any point, and we will do our best to help you out. Or if you have suggestions, feel free. Alrighty. Yes. Okay. And then again, next week is the mental health one. If there were any more questions, I'll take a look at anything here. But as a reminder, if you registered, which if you're here, you registered, that means you'll get all these links as well in the follow-up email. So we're happy to help you out. And again, there was so much information. So if there are any questions, happy to help here. And if there are any.
I think we have the survey.
Okay. Yes, yes. The survey will pop up when you end the call, and it'll be in the follow-up email as well. So if for whatever reason it doesn't show up, it'll be there. Oh, it's also in the chat too. It takes about 2 minutes. It's very quick. You can skip questions if you're like, I don't know. Any of those things. All right, great. If there is anything else, I will wait a moment to see anything in the chat if there is anything that comes up. But otherwise, thank you all for joining us. It's been great to have everyone on board.
Emma, are you going to do a Q&A with Brian and Kaylee, or should we hop off?
I can. I just wanted to check since it was 12. I didn't want anyone to stick around if they needed to go. But in case you are interested, I did want to talk a little bit about Brian and Kaylee's backgrounds and how they got here. I'll go ahead back to the Q&A slide as well.
Good luck, everybody. I need to hop on another call. But thank you so much, Brian and Kaylee, for joining us and for putting this together. Of course, Emma and Roland. Great job again. And for everybody tuning in, thank you so much. Take care.
Thank you for the
Thanks,
invite.
Charlie. If you want to hear any behind the scenes, you're staying on to hear some stuff about how you got to be where you are, making it very cool. All right, well, just to start off, for both Kaylee and Brian, thank you so much. I want to know where you both got started and how you got to this place in this career. So I would love to hear from both of you. Whoever wants to start, you're welcome to. How did you get to this?
Yeah, sure. I'm happy to start. So I think one of my favorite lines that I usually say when I'm speaking to STEM experts is that Girl Scouts were not STEM experts, we're experts in girls. And I think that kind of speaks true to my own background as well. I grew up in a very kind of STEM-based family. My dad's a brain researcher and my mom's a nurse. So they always kind of nurtured in me that love of science. In high school, I went to a school that was very STEM-based, but I wasn't necessarily the best in the class. So I wasn't necessarily supported more than make sure I pass. In college, I found a focus kind of more on helping people. So I studied international studies and eventually found my way to a job in girls' education. Eventually, I wanted to move kind of back into domestic work. So I found my way to Girl Scouts and back full circle to helping people and girls in the US, but through STEM. So I really kind of love that STEM can be a tool to make a difference. So that's kind of where I've found my niche, I think, within the Girl Scouts and STEM world. So I've been at Girl Scouts for about 5 years, and I really just love learning about the subject. So every year, like I said, I'm not an expert. We get different types of projects. So sometimes it'll be something like automotive engineering. I know nothing about that, right? But we have the year to learn about it enough so that we're able to teach it to girls in a way that's fun and engaging, as well as easy enough for a volunteer to deliver.
That was excellent. Wow, that's quite the background. I can relate a lot to the whole situation of like going through schools. Like, it's important, you will pass, we will make sure you pass, but also don't stress yourself. Like, it might come back, maybe you're not into it. I feel like that's a very common like experience. So I'm glad that that you are where you are, so you can share that as well. Awesome. Brian, how did you get to where you are?
Yeah, so it's a long, convoluted story, but I always wanted to do something science related. I started at University of Pittsburgh in the pharmacy program and realized I didn't want to do that much chemistry all the time and for the rest of my life. So I left pharmacy. It's a great trade and everything. It just wasn't for me. But I always loved earth science related. So I transferred into the Earth and Planetary Science department at Pitt. And I wanted to focus on doing research and to be able to teach. So after undergraduate, went into graduate school at the University of Pittsburgh, graduate school education to teach earth and space science. So I went, got advanced degree, and then went and got my teaching certificate in the state of Pennsylvania. So then I didn't even actually teach in Pennsylvania, only student taught in Pennsylvania during college, and then moved to Maryland and taught high school science for 4 years. And then as I was a high school science teacher, I applied for an internship as a teacher, as a science teacher ambassador at the NASA Goddard Space Flight Center in Greenbelt, Maryland. So I did that for the summers of 1999 and 2000. And then in 2001, a position came up and I went to NASA. Basically, I started off, writing code for developing websites before we had all these fancy templates out for building websites. I had to write it all in, Unix-based, language. So I had to write it from scratch. And then I said to my colleagues, I said, hey, that's not what I'm trained for. So I'm going to do something other. So then they put me on a bunch of missions. And, since I had the education background, it was a combination of doing the science and then communicating that science to everyone and making it make sense in the real world. And, so for the last, about 22 years, that's what I've been doing at NASA. And, how I got involved with trees is because I originally started, one of my missions was the original ICESat satellite, which was in space from 2003 to 2009. And that also measured tree heights as well. So I had an interest in that, but I was doing lots of other stuff, looking at the heights of everything basically with ICESat. And then, I joined the GLOBE program, which I don't remember now, maybe 2012, 2013, since it's primarily a NASA funded program with support from NOAA, NSF, and the US State Department. I went and, we started talking a lot about how do we tie in the NASA satellite missions with the GLOBE observations that the students and weren't citizen scientists yet per se, but the students and teachers were doing in the classroom. So then, that started building up, and we did the GLOBE Observer. And, since I've been doing this with ICESat and ICESat-2, I became the tree science lead because, a lot of my focus was on the trees. So that's basically where I came from. And so I've worked on lots of other missions, like a soil moisture mission and Landsat and, global precipitation measurement, ground validation, and, coastal observations and all this stuff. But basically tying all that information in and making it make sense in the real world, talking to fellow scientists who might have problems, simplifying the content, that's where I come in. So I come in and help simplify the content and do that research and, work with the citizen scientists and students from around the world. You're on mute.
Sorry,
Yeah,
I
there
thought
you
I wasn't muted. Sorry about that. That's incredible. Honestly, you're living the life I want in the future, the whole communication. I used to be a science and math teacher for 5th grade. And so the whole idea of communicating that to the public or being able to communicate, that's like the best part about this, is being able to say, hey, here's a bunch of people who know a lot of science and are involved in this stuff, and we want to teach you all to do it. And that's the beauty of citizen science, is you can get everyone involved. So yeah, so happy that you have all that to share with us. And then I just wanted to ask, not about the projects necessarily, but I'm curious what your favorite parts of all this work is. Like, maybe this is like your job in general, or like a specific project, even like for Kaylee, maybe it's these like your favorite part of this Girl Scout, think like a scientist journey type projects, whatever you think is like the thing that gets you super excited about your work. I would love to hear.
I think for me, what's most exciting is that we know how much Girl Scouts want to take action and make a difference in all these different areas, on social issues, but especially on the environment. And citizen science, of course, is the opportunity for everyone to be able to do that. Right. So I think with the different programs I spoke about, as well as all of the Globe Observer protocols, I think it's exciting because you're not just having the opportunity to do the scientific research, but you're also learning these different skills, be it like measurement or problem solving, that you can utilize whether or not you go into a career in STEM. What's more, like when you're doing a citizen science project, you're really able to kind of connect with different organizations and groups that are really already working in this space. So be it the climate space, or water issue space, and you're able to learn more from the scientists, of course, but you're able to work together to kind of make that more community problem solving based solutions. Yeah, I think that's kind of my favorite bit of it, but I think that's also my own personal bias, as I told you, where it's really kind of how to use STEM to make a difference. But I think that's it.
That's awesome. Brian, what about you?
Yeah, I think two things that my favorite part of doing all this is, one is that, the moment when someone like a student or a citizen scientist takes a tree height observation and then is able to see if the satellite, and they're like, hey, that satellite saw the same tree I did, so that's very cool. But the gee whiz moment when the citizen scientist or student or teacher took observations, and those observations are actually being used by NASA scientists, whether it's in their research or in a research publication, which we just published a paper back in June, where we used a bunch of the student and citizen science data, in our paper to compare the satellite data to the ground-based data. So, I think it's that, like, having the students, educators, citizen scientists, see that their data matters. They might take one observation, might take 1,000 observations, but all of that matters, and they see that it's actually being used and that they're part of this larger NASA mission and objective to understand our changing planet.
This is excellent. I can't wait to take sound bites out of this conversation. Awesome. Thank you so much. Is there anything else that you think we should know about this project or your life in general, and how awesome, or how we can motivate people who watch this recording maybe later, or the 16 of you who are still on here, I guess, or the 12 of you who are still on here. Actually, is there anything from any of you that you're curious about from these friends? Just wait a moment. Maybe not. That's okay.
I saw lots of cool things in the chat, from teachers to foresters and everything. So I'm glad we have a great contingent of people here, that will use this data. And, I think, the takeaway is, every single observation that's taken is useful, at some level to the science community.
Yeah, absolutely. Can't be afraid of making those little errors. We gotta just get practicing, and then boom, you start being a efficient citizen scientist. All right. Any last thoughts, Kaylee? Okay. Awesome. Well, thank you all for joining us, and thank you those of you who are still on. I'm glad you got to hear a little bit. Oh, just kidding. There's something in the Q&A. Sorry, Valerie. I'd like to know more about the Girls Climate Action Project. How many girls are participating in this? Oh, do you have the stats by chance?
Ooh, I don't actually. It's our first time doing it. So if you are a Girl Scout or have been on our website, you'll see that we often have a couple of different annual challenges. So in particular, there's the outdoor challenge is one of our most popular that happens over the summer. So this is our actually the first time running the climate challenge. So we're not really sure. I don't have the stats behind it right now, but it's really exciting because I think it takes what girls are doing with citizen science and kind of takes it to that next level. So citizen science is really how you're exploring climate science, and then it's figuring out how are you uniquely impacted, how do you connect with your community, but then how do you work together to really kind of share hope and solutions for what we can do.
That's awesome. Okay, yeah, I'm curious how it'll end up then after this first trial year. It's like the numbers will roll in, or the commentary will roll in, the success stories. That's awesome. Oh, thank you. I think it's wonderful. Thank you. If you have girls in the Annapolis area, I'd be happy to give them ideas for projects nearby for us, etc. Oh, awesome. Yeah, I mean, I'm sure there's like a network of communication, right, between troop leaders and such. I mean, I wasn't a Girl Scout. I'm horrible. Sorry, I was not one.
No worries. What I can do is I'll drop into the chat right now our council finder. So please feel free to reach out to your local council. I'm not sure if every council is running the climate challenge, but I know it's something we're trying to push nationally right now. So that might be a great resource for your local council.
Oh, that's awesome. Oh, you work with Brian. Oh, that's awesome. You were a brownie. Okay, I did make it to brownies, Valerie. I also was a brownie for a minute. It was my sister's thing. It became less cool because she did it. All right, cool. Amazing. Okay, well, that's great. I'm so sorry. I'm definitely going to close out this meeting. We're 13 over. Thank you all of you who stuck around. So happy to have you all sharing these resources. And we will send you the follow-up email. I'm so excited. Thank you so much, Kaylee. It's been a pleasure having you on here. Thanks, everyone. I'm going to go ahead and end there we go.